I think we can start now. Uh, Welcome all participants. Myself Samir Patel. I represent Cooper India Private Limited. We are a channel partner for Omega Nutrition Singapore. And today we have invited you to participate in the seminar. Particularly, we have one patented feed supplements, that is activated guanidinoacetic acid, which is a creatine precursors, and we have invited Dr. Rais Rajpura to present about today's webinar, and he will give his talk on this activated guanidinoacetic acid and how it is helpful to optimize the feed cost in poultry industry. Dr. Rais Rajpura is an assistant professor at the Anand Agriculture University and Department of Animal Science since long, and he's well known and renowned in poultry industry since very long, and worked with broilers, layers as well as breeders. So I invite Dr. Rais Rajpura to present his presentation. Welcome, Dr. Rais Rajpura.
Thank you very much, Sabir Bhai. Cooper India Private Limited and Omega Nutrition Singapore for providing me an opportunity to discuss and to deliver a talk on the newer topic of that is guanidinoacetic acid, GAA. This topic is not discussed yet in the world, or in the last 4 or 5 years people started to talk on these topics because these are very new molecules and new things is there, which is used in the feed as a feed additives. So we will discuss on this. I will hope all of you, my screen is visible to you. Okay. So the topic which is assigned to me for today's presentation is activated guanidinoacetic acid, that is GAA. It's a creatine precursor, and we'll discuss a novel approach for feed cost optimization and performance enhancement through cellular energy. So here for today's audience, some new word is there, that is a guanidinoacetic acid and cellular energy. So this too is a new topic, a new discussion which will go on today. So in our today's discussion, we'll go with the revolution in feed formulations, then what is a guanidinoacetic acids, what is a creatine, what is arginine, what is cellular energy. This all aspect we will discuss. Then effect of this guanidinoacetic acid, that is GAA. I will use word GAA on the growth performance, FCR, meat quality, and reproductive performance, and then take home message. So when we see a poultry broiler or layer or breeder formulation, feed cost is like 70 to 80%, that you all know very well. So in this feed formulation, since last 30 years, only last 3 decades, what happens in initial days when we start to formulate the feeds, we have used the precision feed formulation methods and softwares to make the feeds. Like this is a precision feed formulation. Then we have started to use all this high-end softwares, linear feed formulation softwares to make a precise feeds. We will not waste any money. And then we started to use all the essential amino acids, and the list is like lysine. Then we started with the methionine, then threonine, tryptophan, valine, and so on. In future also some amino acid will come. So we have done the feed optimization at this levels. Along with that, whatever hidden potential or hidden undigestible nutrient is there, we try to explore with the enzymes. And that is NSPase, phytase, protease, lipase, and even emulsifier. So this part that is called as feed optimization, that we have taken care with this enzymes and emulsifiers. So we can get a maximum nutrient back from the feeds, and maximum nutrient can be digested by the birds, and it is uptake by the bird. So that part we have already done in the last 30 years of our nutrition research and feed formulation. In future, or this newer things, that is the cellular energy. This is topic that we'll discuss today, and this future topic or future areas where again we do optimization and we can get a maximum performance. And that cellular energy, that is through adenosine triphosphates, creatine phosphate, guanidinoacetic acid. So with all these things, will use a cellular energy. How we utilize best way the cellular energy for maximum performance, that we'll discuss today. So this is like enzymes. We are generally taking this of the nutrients back from the feeds, and we are formulating the feeds. And why this cellular energy concept is required? Because we have all are making a very precise feed formulation, and we have a limited feed ingredient resources. You know very well. And in the last 10 years, we have seen that the prices of the energy sources is shoot up. So the feed cost is increasing. So we are trying to maximize the feed utilization. So in that, in the supplements and this GAA will help to optimize the performance of the birds with the cellular energy. So now, what is GAA and what is cellular energy? That is to be discussed first. This presentation, in that I will try to explain you some biochemistry levels, how the cellular energy work, so we can understand the subject properly. So what is a GAA? First, the GAA is known as a glycosamine, or it's a amino acid derivatives, means it is formed from the amino acids from glycine and arginine. These are the two amino acids in the body which unite, and with other enzymes, it form a GAA. So GAA is been tested as a potential sedatives to enhance energy utilization and growth performance of the poultry. GAA has been explored as an effective alternative to creatine. We'll also discuss why creatine is important, and GAA is also a good to outcome as a arginine sparing in the bird. So we'll also discuss what is the importance of arginine, and this is all something about the GAA. And in body, when we are giving the feeds, we are giving the proteins. In the proteins, there is an amino acids. There are two amino acids there. One is a glycine and one is a arginine. When these two amino acids unite, and under the influence of this hormone L-arginine glycine aminotransferase, the GAA is formed in the body. So bird itself produce GAA in their kidney, and this GAA is converted into creatine in the liver. So liver, here two organ is involved in this maximum GAA production. One is the kidney for GAA production and liver for creatine production. So GAA along with the methyl donors and this enzymes guanidinoacetate methyl transferase, these three things is required to convert this GAA into creatine. Now, what is the importance of creatine? Creatine will store the phosphate, whatever phosphate in the cell is there, that is the store in the form of creatine phosphate. So the creatine phosphate is a reserve source of phosphorus for ADP, which is converted into ATP. So we'll also discuss how ATP to convert ADP and cellular energy is there. So here you can understand the GAA itself produced in the body, but it is not sufficient in the quantity that is required by a modern commercial broiler birds or high performance birds. That's why the feed supply is important from the GAA. We can supply a creatine also in the feeds to get this performance, but creatine is not feasible in the poultry feeds because they heat stable. So in pellet formulations and in other pellet formulations, when we are heating the feeds at 85 to 185 degree temperature, the creatine is not stable and it's a costlier affair. We can increase the arginine also, but again, other than arginine, along with arginine, if you use a GAA, it is better. That also will discuss. So this is about the synthesis of the GAA in the body. And this all GAA with enzymes and methyl donors, that is in terms is called as activated GAA. That product what Samir bhai will discuss. So this all about GAA. Now we'll see what feed we are giving to the birds, how it is used. Once we are giving the feeds to the birds, that is ingested, that we all know, then it is ingested by the birds, and it is digested in this intestine by the enzyme. So enzymatic digestion occur in the birds, and from the carbohydrate, glucose is there, proteins, amino acid is liberated, fatty acids, and fatty phosphorus. So this all a nutrient is absorbed in the body. Once this nutrient is absorbed through the intestine, it goes to the blood circulation. Okay. From this blood circulation, this nutrient goes to the cell that is whatever our body is made up of cell. So in that cell, we have already studied that the mitochondria is a powerhouse of the living individuals or the body. Our body's powerhouse is mitochondria. So whatever the nutrient we are giving to the birds, that is converted into amino acids, and carbohydrate to converted into glucose, and fatty acid converted to fat is converted into fatty acids. This goes to a cellular metabolism, and ultimately under the Krebs cycles, you have to understand the biochemistry also. Krebs cycles, it produce the ATP, that is adenosine triphosphate, and this ATP is a currency of cell. Means whatever feed we are giving, that ultimately it is to be converted into form of energy in terms of ATP. So now understand that ATP is the ultimate source of energy for cell. Cell don't know glucose, cell don't know carbohydrate, cell don't know maize. They know energy as a source, energy source currency, that is ATP. And from this energy, whatever the function of the birds, like maintenance, growth, production, reproduction, that occurs, that is through the ATP. So it is clear that ATP is a energy currency. So in this ATP, this is the structure of ATP. In the structure of ATP, there is a adenine sugar, then ribose sugar, and this phosphate group. In this phosphate group, the energy is stored. This phosphate group, this energy is stored. Around 8 calorie energy is stored in this phosphate bond. Here less and here less. So maximum energy is stored in this bond. And when the body need energy, when body need energy for growth, when body need energy for maintenance, for performance, for stress, everywhere, where every cell need energy. So from that phosphate bond, the phosphorus is released, and from this bond, for if every ATP is producing the energy, 8 calorie energy, and this energy is utilized for the maintenance. So now it is understand that for feed which we are giving to the birds, ultimately at cell levels, it is converted into ATP. ATP will store this energy in that phosphate bonds, and whenever body cell is need, that phosphate bond is released and energy is released, and that energy is utilized for the maintenance, growth, and production. So this all about the biochemistry. So like when the ATP release their bond, that come ADP. That is just you can imagine ATP is your charged battery, and ADP is your discharge battery. Or now we have the battery like a rechargeable battery. So does it we can recharge this ADP to ATP? Yes, this is ATP cycles. So in that, we have already discussed about the guanidinoacetic acid, then creatine, and guanidinoacetic acid, that is GAA, converted into creatine into converted to phosphocreatine. So phosphocreatine, the creatine also store energy in the form of phosphocreatine. So whenever ATP lose their phosphorus and become ADP, again this reserve phosphorus, it's a reserve phosphorus which will utilize by ADP, and again ADP become a charge. So this is endothermic and exothermic reaction is there, and this energy is again stored. So always, so in this cell level, this energy cycles will working. So the question is that whether body can recycle or regenerate ADP from ADP? Yes, creatine phosphates is one of the way to regenerate the ATP. This is a human because in animals and poultry there are very limited this kind of research is there. So this is from the human. A human body can produce around 250 gram of ATP daily, but uh, but the recycling is possible. So entire body weight means 80 kg body weight is there, and 80 kg of the ATP is recycled through creatine phosphate. So creatine phosphate is a reserve source for the energy for the ATP, and ATP is a reserve source energy for the cell. So this way we can say that the creatine phosphate, which is produced from this guanidinoacetic acid, will help to give extra energy to the cells, and the work is will be done. Like in rest, uh, birds have very minimum requirement. So phosphocreatine and ADP is there, and at work ATP is released, energy is released, and work will be there. This way, the things is going on the body. When there is a ATP deficiency occur in the body, what happens? And why this ATP deficiency occurs? Most of the times, the P deficiency issue is there, or mortality issue is there, or cellular death is there, and because of that, bird may be dying because the rapid and fast growth of the birds required more energy, so where important amount of ATP are absorbed from the protein synthesis. So in that we need a more creatine phosphate pool to produce to recycle this ATP. In excitement and stress, like in stress, even in cold stress also, we need a more ATPs. In low oxygen supplies, that is in the winter or even in the summer when birds is excessive panting, low oxygen supplies leading to low ATP production, because this cellular energy is a cellular respiration will be there. If low oxygen is there, ATP production is not there. And disturb energy metabolism, that is if mitochondria, this mitochondria is the powerhouse of the cells, if they disturb, the energy metabolism will not be there. So that's why we have to think on creatine phosphate pools or reserves through acetic acids to supply a consistent supply of this ATP. So what is the requirement of creatine in case of the broiler birds? This is a 2019 aviation required around 169 milligram of creatine per day. This is based on the calculation that a 50% growth, that is 35% growth, is there in the muscles, and each muscle tissue contains 4.5 gram of the creatine. So the creatine requirement of the modern commercial broilers is too much high. And if you fulfill the creatine requirement, creatine phosphate, through the guanidinoacetic acids, our performance will be enhanced. Even though the creatine can be synthesized by the birds, is not enough to meet the high demand of modern broilers in terms of performance and the growth level. So creatine supplementation via the diet therefore be beneficial for the poultry. But as I told you, creatine is not feasible to give in the feeds. That's why their precursor, that is GAA, will help to convert into creatine and creatine to creatine phosphates. Previously, or as on today also, we are using this creatine is available from the non-veg sources. It's a muscle. No plant sources contain creatine. Only animal protein source contain creatine, and that is also the level of the creatine is questionable, because like meat and bone meal is that is rendering, and heat treatment is done. In that heat treatment, creatine is destroyed. Like in our all muscles, creatine is stored because muscle produce creatine. But under the heat treatment, this creatine is destroyed. So in the meat and bone meal, creatine is there but may not be active. In fish meal, a very good amount of creatine is there. Poultry byproduct meal, creatine is there, but the amount is very less, and which is not, when we are getting through 3 to 5% of these animal protein sources in feed, they are they are not giving a sufficient amount of creatine. And even in a veg diet, when we have a pure no animal protein sources in animal our poultry feed, it's a veg diet, there is a creatine deficiency and a GAA deficiency. That's why we have to give this guanidinoacetic acid supplementation, that is GAA supplementation. which is to be stable feed additives in animal feeds. By this is given by European Safety of Food Authority. GAA supplement 40% lesser cost compared to creatine. Creatine is a costlier. In human, those who is going to gym and those who are making the muscles, they are taking the creatine to make the muscles, to make their body, to maintain their muscles and body. You know very well the people's that is all this protein shakes and they have some creatine supplementation. The GA has been tested as a potential supplement to enhance this all growth performance, feed conversion ratio, meat yield, and reproductive performance, enhancing creatine concentration in muscles, liver, kidney, plasma, leading to better growth and performance. This is studied by various scientists. In the last 10 years, the research on this GAA is actively gaining the momentum, and whatever research paper you will say, that is of the last 10 to 15 years. Before that, very few research article is there who discuss on this GAA supplementation. And GA also exerts some non-creatine roles, including stimulation of the insulin secretions, neuromodulation, and vasodilation. That's why GAA is a good source compared to creatine for the creatine phosphate pool. One more things we have seen in our nutrient recommendation, that is arginine. As we are growing the birds at higher meat yield or higher dressing yields, we have seen that in the last decades or last the nutrient recommendation, the arginine requirement is going higher and higher compared to the lysine. Like initially, 15 years back, when we have a slow growing broilers or low growing broilers, we are maintaining 1:1 ratio of 1:1.05 ratio of lysine to arginine. But in modern birds, the arginine ratio is 1:110 times to lysines. Lysine is a reference amino acids, and lysine to arginine is there because the scientists know that if we increase the arginine content, arginine is converted into arginine with the glycine is converted to GA converted to creatine converted to creatine phosphate, and it will give a helps in the cellular energy metabolism. That's why the scientists increase the arginine amount in the feeds in all modern heavy-breasted broilers. This is for the aviation, this is for the Cobb, this is for the Van Cobb. The arginine requirement is going higher. Like this is the requirement. Say this is the requirement of arginine to lysine. It is going higher and higher. So the question is that if we are giving arginine, then what is the need of giving the GAA? What is the why GAA is work better than arginine? Yes, because arginine and glycine both is to be unite. So glycine is the 11th amino acid. That's why the glycine is the 11th amino acid in the poultry birds. So otherwise in other animals, all 10 amino acid is there. Glycine is the 11th amino acids in poultry. It unite with the arginine and synthesize this GAA. But the scientists say that, or the research says that, in a negative control, that is arginine deficient diet, if you give GAA, it will work better, or better performance is observed with 600 to 1200 gram GAA per kg of per ton of feed applications in a arginine deficient diet. Like here, 28 days body weight is negative control diet, is similar to or almost similar to the arginine full diet. Same way in arginine adequate diet. Suppose we have arginines and we are giving the arginines. Arginine is also available. Arginine adequate diet. If we give added supplementation of the GAA in arginine adequate diet, this is the question of arginine deficient diet. When arginine is not, we are providing to the feeds. If we are providing adequate arginines to the feeds, and if we give a GAA, the performance is even better compared to this arginine. This is arginine positive diet, and this arginine positive diet is made with this fish meal and creatine phosphate creatine. So in a negative control means arginine deficient diet. In arginine deficient diet, if we give GA, the excellent performance will be there. So can GA replace arginine? Yes. GAA can be used as a substitute, or is a arginine substitute in the poultry feeds. So in the broiler show that the dietary GAA can act as a arginine sparing agents while decreasing the mortality related to ascites. This is because arginine helps in the vasodilation, and it also helps in ascites cases or sudden death syndrome cases. Increased dietary GA concentration in a broiler subject to heat stress result into greater plasma arginine. They show more rapidly available for the metabolic process other than de novo GAA production. So if we give a GAA, the arginine will be spare for their own work, because 20% arginine is converted into GAA. So if we give arginine, if you give GAA, sorry, if you give GAA, the arginine will be there for their own work, which is devoted work of the arginine that can be done by arginine. So by supplementation of the GAA, the arginine work can be done in a very good way. So theoretically, GAA has an arginine sparing potential, and we can replace 149% of this broiler. But practically, we can replace the 77% of this arginine supplementation through the GAA by 0.6 to 0.12%, 0.06 to 0.12%. This is an experiment that yes, this experiment shows that GAA 77% of arginine, the equal performance or even better performance is observed compared to the higher arginine. So arginine can be replaced, or in arginine diet use GAA for the better performance. So looking to all the background of the biochemistry and the physiology of the birds, and the interrelation of the arginine, glycine, creatine, GAA, methyl donors, and everything, as practically what we expect from the GAA supplementation. So if we expect GAA supplementation, as it is used in the cellular energy, we can replace some part of energy with the GAA supplementation. That will directly help to reduce the feed cost. That is a reformulation diet. Now on top application, all the performance enhancement will be there. As it provides the energy, the increase in the body weight and weight gain. It definitely improve the FCR. The breast meat yield and dressing percentage is increased with GA supplementation. As we are growing birds higher and higher body weight, there is a muscle degeneration, that is a muscle degeneration that can be prevented through GA. In heat stress, when there is an active requirement of this energy, and in ascites, there is a requirement of the arginine. In that case, these cases can be reduced. In a male breeders, this GAA will help to improve the semen quality and the fertility, that is in penetration and activities of the males. In the female breeders, if we are using this GAA, it improves the chick quality, because the GAA is deposited into the eggs and will help to improve the chick quality. So one by one, we will see what research has been done by the various scientists, and to get the maximum efficiency or maximum potential, or to get the maximum potential from the GAA. So first, when we use the GAA, it increases the body weight. This is the research which is compiled by the Kijali and their co-workers, that is geoconidinoacetic acid, the feed supplements for the poultry in 2020, just 2 years back, 2 years before. And this is a compilation data of almost 30 research, and it shows that when we add GAA, it increases performance. It increases the performance. In most of the research, it shows 0.06 to 1.2% inclusion level. This GAA increase the body weight. Means there is a direct weight gain is there in the birds. This is a research. Same authors compile the research data on the breast meat yield. Breast meat is generally 25%. Whatever normal is there, that is 100. And from 100, how much percent is increase? So around 6 to 8% increment in the breast meat yield is there. Breast meat yield I am talking about. And in dressing yield, almost scientists observed 3 to 4% dressing yield more in case of the GAA supplementation. This is again research show that the GAA supplementation increase this weight gains and even the breast meat yield. See, there is a mark and the FCR is improved. So the GAA will helps to increase weight gain, better FCRs, and more breast meat yield is there. So this is improve in the weight gain and body weight and weight gain. This is from the Ross 308 meal broilers. This again, this paper was published in this recent last year 16th European Symposium on Poultry Nutrition by Ringel. Now we are going to increase higher and higher muscles or breast meat yields, and you know that there is an issue in the breast meat yield also that we'll discuss. So the GAA, this research is published. The GAA is a novel food for the skeletal muscle growth. It's a direct endogenic precursor for the creatine, and GAA might have yet another role in the muscle growth promotion. So it's a food or it's a good for the muscle growth. And the issues when we are growing, I told you that when we are growing the higher meat muscles or higher meat parts, the white stripping or woody breast condition is higher in case of the high 2.5 kg to 3 kg broiler birds. We do not want to produce 3 kg broilers, but in 2.5 kg broilers also some woody breast and breast abnormal muscles are there. Does this weight abnormal muscles can be correct or can be short out with the GA supplementation? Yes, GA will help to reduce the broiler breast muscle myopathy. So whatever the white stripping is there, woody breast is there, that kind of the issue can be short out with the GA supplementation at 1200 gram per ton of feeds in a broiler diet, reduce breast myopathy including woody breast and other issues. Like this is research with this GA higher doses of GA supplementation. See, in a controlled diet, 1.38% woody breast is there, 1% means 38% reduction is there, means lesser number of woody breast cases is there in the GA supplementation. This WS means white stripping is there. You have seen that on the muscles, white strip is there. That is not liked by the processor. This GA supplementation, higher breast meat is more focused by the processors or those who is doing in the processings or those who is producing the high breast meat yield muscles or those who is producing more boneless meat production broilers. They are focusing more on the arginine and GA supplementation. So by adding the GA, we can reduce the incidences of the muscle myopathies and muscle degenerative cases. So this is one I want to discuss with you. So this is all about the meat yield, or that is a body weight gain and the growth. How we take the advantage of GAA in a reduction of feed cost. So if we are using enzymes, that is separate issue at that work at the intestine levels to release the inbound energy or whatever undigested nutrient is there, that is released to the enzyme. So don't confuse with the enzyme matrix value and enzyme energy value and GAA energy and matrix value. So if we are taking enzymes matrix value, then reasonably we can take 30 to 40 calorie from the GAA. Means 100 calorie if we are taking from the enzymes, then 30 to 50 calorie depending on the diet energy concentration, we can reduce the energy in the feeds and we can optimize the feed cost. If we on top application, then there is another better advantages in all performance enhancer. In feed cost optimization, this will be there. If we are not taking this matrix value of enzyme, then we can take more energy, from 100 to 120 calorie energy we can consider from the GAA, but it's not possible in commercial feed formulation. Today we are taking a good amount of energy matrix value from the enzyme. So 30 to 50 calorie energy can be reduced, 30 to 40 and 50 in case of the finisher diet. So this one research is there, which showing with the control means with the regular energy value as per the breed recommendation, control as a breed recommendation. This negative control means 80 calorie less energy. This is a control. This is on top application. This green bar is on top application, and this purple graph is for the reformulation diet, that is negative control, means minus 80 calorie plus addition of the GAA. You see, on top application, the performance is higher. So body weight gain is more, better FCR, and better European efficiency index is observed on top application. But when you reformulate the feeds, in the reformulation, compared to the negative diet, the reformulation giving a better performance. Means in this GAA group gained 59 gram more body weight per birds and score 4 point FCRs and showing 4% improvement in the EA. This is again recent research of 2020 only. And so this way we can use GAA in the feed cost optimization. So FCR in a GAA dose between 0.6 to 1.2 gram per kg, that is 600 gram to 1200 gram per kg, suggested 4.5 to 8.8 FCR improvement is there. This is depending on our operations. We can get this kind of performance. This all, like in previous slide also I showed you the compiled research of Dr. Khijali and their co-workers. Here also they have compiled the information on the FCR. You see all of the experiments showing the better or improvement in the FCR, except one research. It means that there is this GAA application. This all is of like 40 to 50 research article combination is there. The 40 to 50 research shows that the GAA supplementation at a different dose, like here 500 gram and 1 kg to 1.2 kg, there is a graded, there is an improvement, or the performance FCR is improved, the graded increase in this 1.2. The 1.2 is a maximum inclusion levels in a GAA application. Above that, there is a negative results is observed. See here, the negative results is observed above 1.2 kg. So standard GAA, whatever research and whatever the literature studies is there, and even practical implication is there, it shows that the GAA can be used from 600 gram to 1.2 kg per ton, depending on the diet concentration and the birds. So now we'll discuss something about the heat stress. This is all about the performance enhancement is there, and FCR improvement is there, breast muscles improvement is there. Now, what role of the GAA in case of the heat stress? So you know well that in acute heat stress, the cellular energy demand is increasing. This is as per the the research. That in acute heat stress, the cellular energy demand is increasing, and during the chronic heat stress, the mitochondrial adenosine triphosphate generation is reduced. Means the cell is not getting sufficient oxygens, and in that case is the ATP production is decreased. If you know well, now you understand that if ATP production is decreased, from where cell will get the energy, and because of that, cell may die, and if cell will die, body will die. So in that case, and in a heat stress induce higher utilization of muscle energy reserves in the form of glycogen, and even in excessive panting, birds need more energy during the summer stress. So that energy can be through ADP ATP gene generation cycles, and for that the creatine phosphate is a reserve full. It's like you're full of go down with the reserves phosphates for ADP to ATP generation. So fast energy can be released from ATP. So cell only utilize energy from the ATP. No other source is there. So high ATP produced from the phosphate reserves. So enhancing cellular creatine phosphates energy shuttle systems might offer benefit for the broiler subjected to heat stress. So this all indicate that in a heat stress condition, the GAA can be performed or can be give good results. The function as a adenosine triphosphates metabolism energy can be required in short notice. This you just think that this ATP pool, the function as a backup to the adenosine diphosphate ATP cycle to store and metabolize energy when required in a short notice. Because when there is a heat stress and there is acute stress, the birds need energy in a short time. So GAA feeding improves survival during the heat stress. A chronic cyclic heat stress models a temperature of 34 degrees centigrade, 50 to 60% relative humidity for 7 days daily was applied in a finisher phase, supported by lower panting frequency, plasma arginine was higher with increase in the dietary GAA concentration, and the performance is high. So this is about the hysteresis and GAA. Same way, the GAA also helps to reduce the cases of ascites in case of the broilers. So this is all about the broiler performance and broiler studies. So how now we'll discuss how the GAA will help in a breeders. Like in breeders, the sperms are there, and in the poultry sperms are like this sickle shape, and a very less amount of energy reserve is there. Like mammalian cells, they have energy reserves, but this poultry cells less energy reserve is there. So when the sperm movement is there, to move their sperms, the sperms need more energy. So that ATP, if we have the sperm is a cell. So in that, if ATP pool is there, the creatine phosphate is there, it will give ready energy to the ATP ADP, and the energy will be utilized by the cells, and the sperm penetration is increased. Like the creatine precursor GA play important role in the proper function of Sertoli cells and energy metabolism of the sperms. 29-week-old breeders, this study is done, and in that it showed that the fertility rate was significantly increased at level of at this all level of GA supplementation. Means in breeders we use 600 1.2 kg or 1.8 kg, the fertility rate is increased. Feeding broiler breeders with GA 0.6 to 1.2 kg increase sperm penetration and improve fertility in the experiment. Means the sperm penetration in the ova is increased, sperm movement is increased, liability of sperm is increased. If the liability of sperm is increased, definitely the fertility is increased. So if I have a fertility issue and we have done all sort of the treatment and everything is done, even the fertility cannot be increased, this may be the one solution we can use to improve the fertility in case of the breeder males. These are the research. This is research experiment, so I can focus on this Zhang research in 2016. They showed that the hatchability increased from 86 to 91% in the breeder hens. So this is all males. This is for females. The hatchability is increased from this. So in this about male. What about females? In a females breeders increase the availability of creatine in eggs and muscles and muscles for progeny, with consequently better postnatal progeny performance. If you give a GAA in case of the breeder female, the more amount of muscles creatine will be there in their body, more amount of creatine not GAA, creatine will be deposited in the eggs, and when the embryo growth is there, and the last day when there is energy demand higher, in that time this energy creatine will give a readily available energy as a creatine phosphate. And the research shows that the performance and carcass characteristics of progeny, that is meat characteristics of progeny, that is originated from the breeders fed diet with the different level of GAA when compared to those on the control. The GAA supplementation of the parent feeds significantly improve the FCR in the progeny up to 0.8 gram per kg. Means this 8 point FCRs can be improved if we are adding a GAA in the breeders. The breeder progeny have higher in the first week, they have higher this creatine phosphates, and this will give more performance. So if I will compile all this information on this GAA, my take-home message to all the participants is there. GAA has a potential effect on the reduction in the feed cost first, improve bird performance, improve feed conversion ratio, increase breast meat yield and overall meat quality, and decrease hysteresis and ascites mortality, enhance reproductive performance of the breeder. So maybe this one molecules have the all sort of functions and all sort of activities and the performance enhancement in our modern commercial broilers, even breeders, and even in the laying hens. So thank you. With this, I will complete my talk here. And if participants have questions, then we can take the question. Samir bhai, over to you.
After a long time, I think we have very good technical information on product. So particularly before taking a few question and answers, just I will give just 2 minutes.
Okay, then can GA replace the antibiotic growth promoter and protein? No, sir. GA can't replace antibiotic growth promoter. Antibiotic growth promoter is something different. GA is something different. So it's not can't replace. And Dr. Bhutani says that what about the performance of GA in the layers? The same performance which we observe in the broilers can be observed in the layers, but layers in terms of production, we have a good number of eggs. That is, egg production is increased. Maybe if we are giving on top application of GAA, feed consumption is reduced, and in layers, if we reformulate the diet, the performance, the feed cost optimization is there. And another is if we add GAA in the layer birds, the more creatine production is there. So the egg contain more creatine. So this may be the one advantage. So in future, if anybody wants to market a more creatine enriched eggs, then in that case, GAA will be the answers to add in the feed. So this three phase, we can take the advantage in the layer birds. Even stress mortality reduction is also there, as I discussed. Next question from Vani. Mr. Vani is there, sir. Can you please repeat the use of enzyme along with the GA? Okay. The enzyme application is a parts that we are already doing in our formulation. Most of the nutritionists and those who are doing feed formulation, they are taking the good amount of the matrix value of enzymes. So when we consider a matrix value 100 calorie energy from the enzymes, that you can take it from 100 calorie from the enzymes, but from the GA you can take only 30 calorie energy. It is not like that I am taking 100 calorie from the enzymes and 50 to 70 calorie from the GA. Your performance will be disturbed. If you are taking lesser energy or lesser matrix value from the enzyme, like 50 to 60 calorie energy, from GA you can go slightly 10 to 15 calorie higher application from the GA. So altogether, all nutritionists will say that we can't replace more than 130 to 150 calorie with any sort of this application. So altogether can be replaced 130 to 150 calorie depending on the diet energy concentration.
If anyone have more questions, you can type in chat box. Meanwhile, just I will take 2 minutes. Just I will introduce this company. This Numega Nutrition is a Singapore-based company, and with the collaboration of University of Barcelona, Spain, they have developed 2 products. They have only 2 products, and both are patented technology products. One is a NTPB, which is activated GAA, and another is a Megacid, which is a paraformic acid. That is also patented product. And this particularly, there is so many things Dr. Rais has discussed about this GA. Now, what this our NTPB is, it is an activated GA. Because see, when the GA to get converted into creatine, it needs to be methylated with methyl donor, and it is to be activated by transferase enzyme. So NTPB is already pre-activated product. So unlike the other GA, it will give a better performance. You can see this whole cycle already discussed by Dr. Rais Rajpura. That this GA, when it is methylated and activated by enzyme, get converted into creatine. Now, if we are adding only GA, then it has to depends all this process from the bird's body. So what this all red circle, it is a NTPB patent. And it is already, so this NTPB can faster and easily and smoothly get converted into creatine as compared to simple GA molecules. This is our US patent certificate, and it is also approved worldwide. You can see there is a European Union, they have already approved in 2009. In China, they have approved in 2014, and lastly, even FDA USA also has approved in 2017. So product is very safe to use for the performance enhancing and reducing or optimizing the feed cost. And the major benefits of NTPB is it gives a more muscular weight gain, approximately 2 to 5%. Then it improves the FCR. But how you are using it, whether you are using on top or just reformulating the feed, accordingly you will get the benefit on FCR and arginine sparing effect. So arginine is also valuable amino acids. So if you are adding NTPB, up to 66% of the NTPB dose arginine you can reduce from your feed. So all three are very good benefits by using the NTPB. So this is what about my product is. And if you still you have some more questions, we can take up.
Why we don't use GA directly in the feeds? Is Mr. Hamid asked the question why we don't use GA directly in the feeds. Yes, GAA is available, so we are using, or we can use GAA in the feed directly. And creatine cannot be used because creatine is a costlier. This is one thing. Second is a creatine is a heat stable, heat labile, not heat stable, heat labile. So when we go with the pelletization, the feed creatine or whatever included or added creatine is that is destroyed. That's why creatine supplementation in a poultry diet is not practically feasible. That's why we use GAA. We can use GAA.
There is a question from Dr. Jignesh Barot. Is there any adverse effect on overdose of GAA?
Dr. Vivek asked me questions. Can we expect more egg numbers in breeders due to GAA? Any commercial GAA is available? Yes, Dr. Vivek. We can expect more number of eggs in terms of performance if we have a good this energy is there. Energy availability is there for the feed. Not directly, numbers is increased. And yes, commercial products are available. 3-4 companies who is producing this GA, including this Avonic, Creamino, that is Alzgames, and another is this Numega. These 3 companies are producing. Is there any adverse effect of overdose of GA? Yes, doctor. That's why the recommended dose of the GA is 600 gram to 1.2 kg per ton of feed. That is 0.6 to 1.2% of the feed, 0.06 to 0.12% of the feeds. Excess doses may reduce the performance. So no excess dose to be given. We can use the recommended doses, and recommended doses the GAA perform well. So 600 to 1200 gram is enough dose for GAA, any GAA. Another question, sir, can you, okay, that is already answered. Okay, one more question. Is there any estimating method for creatine from the, yes, methods of creatine estimation is available for the from the eggs. Okay, Samir bhai, I think I had seen all these questions and tried to reply to our participants. Hope they got their answer.
Right. I think if still anybody have a questions, you can even later also you can mail us, WhatsApp us. We will try to reply all of your queries later on also. But it was a nice session. First of all, I am very much thankful to all participants for sparing your valuable time and attending this webinar. And Numega Nutrition is very thankful to you. And even we are also very much thankful to Dr. Rais Rajpura for giving his valuable time in giving the presentation for the activated GA use in poultry feed and various benefits out of by using this NTPB. So thank you very much, everybody. Thank you. Have a great day and good night before.
Thank
Thank
you.
you.
Bye bye
Thank you.
to
Bye.
all.